It is. Oh no, we're not going to finish lecture 1 today. What are we going to do today? We're going to finish lecture 4 with lecture 4 examples that I put up on the website. So last time we were here, I went over lecture number, I don't know, one of these here. I talked about inheritance, I know that part. I talked about property and synthesize, and I talked about building classes and groups. So I have 3.5 to 4, one on protocols actually I may not cover unless I'll probably talk about protocols depending upon the time. I still got plenty of time here. But what I want to do is go over this one here, which is lecture number 4, examples. This will help you significantly with the assignments for this course. If you download the file, you'll get 3 examples. Inheritance number 1 and inheritance number 2 I'm going to cover first. Then I have to give you a little spiel on protocols. And then I'm going to cover a protocol example. So let's take a look at example number 1. So I'm opening it up in Xcode. It should open up in Xcode. I did not create it with a storyboard. Created it without storyboards. So you can open it up in any previous version of Xcode as well. What's going on here? How come it's all red? Why are we all red? And this one is using a storyboard. Uh-oh. I believe red means it can't find the files. Files are here. Let's do this one. I put the, apparently I put the project inside of the project. So when you open up, this is probably a good test because when I open this up here, go inside of inheritance 1, which is inside of inheritance 1. And double click on this one here when you open this up. So I believe, let me just check inheritance 2 real quick here. No, inheritance 2 does not have this problem. It's just inheritance 1 that has this. So inheritance 1 has all of the pieces that we talked about last time put together. So we create a person, we create an employee, we use initializers, and we make some of these instances of the objects, and we see how the data works together. So I want to step through this code so you can see what I'm talking about. You'll need this one for the second assignment, actually. So let me start in with person.h, and I'm going to see if I can figure out how to make this bigger, actually. Does anybody know off the hand how to make the screen bigger? Probably in preferences. Let's see. Fonts and colors, let's try that out. Default. Wow. Just to make this bigger. Oh, well, okay, I'll do this for next time. Text editing, let's see. No. Okay, I'll do this for next time. I have to figure out, because when you're looking at this, when I go like this, it doesn't get recorded. This big text that you're looking at shows up real small in the video. So I'll figure out how to make it bigger in the future. But by the resolution of the project, inside the project? That's what I was just looking for a few minutes ago, maybe in the view. Standard editor. Maybe it's in the window? No. Zoom! Ha! Look at that. I like the zoom. Let's see, window, zoom. I don't think it's really zooming anything though. Minimize, maximize. No, it's not really. You know what? Maybe we have an eyeball down here or something now. What's this? Well, I know there's a way, and I'll go ahead and look it up for next time, I guess. But let me do it this way. But I know every time I've done this and I've looked at the videos, this doesn't look as big as it does on the video for some reason, which is kind of weird. You know what though? Let's see. Let me try something else actually. There's a way of. Oops. Well, not exactly what I wanted. All right, let's just do it this way. All right. So, what are we looking at? So this is a refresher of the memory. This is basically to show you the sample example. And this is what we started with last time, and we didn't actually build it and use it in the driver program. I believe we got this far. Without any inheritance at all, when we create person, we do the colon, and this is the simple interface. So this is the .h file, and this is in person.h. And fortunately for us, Xcode gives us the comments that appear on the top of the screen. So this is a little bit of a review for some, and probably brand new to others who just showed up today. So long story short, this is the declaration of the class, and we have the interface, so the @interface person, colon, and then we have NSObject, which is where our inheritance is coming from. So when we do employee, we're going to go employee colon person. So we have to put this in. If we don't put this in, we end up with an error message. We have integer age. It's not a pointer because it's not an NSObject. It's not an object. So only object reference types need pointers. So this integer age is going to keep track of the age. But you see here, I'm going to do something else a little bit differently here. This is outside of the opening and the closing brackets. I don't have to. I can actually put down here, if I wanted to, put property for age down here. This is what I was showing you last time in terms of the lecture slides, where if I go property, and this is going to be an NS string, I'm using that asterisk here because this is a pointer, name. If I wanted to take this out, I could go property, I could type here, and then I can go integer age, and then get rid of this line right here if I wanted to. And as we've seen before in the last lecture before I showed you the examples, I'm doing this here because I want to automatically create the assessors and the modifiers, which is one of the things you're doing in your programming assignment. So I'm going to take this out because it's not going to give me very much to show as your example if I don't. So for every property here, we have a synthesize in the .m file. So if I click on the .m file, I see synthesize name. If I had age in here, I could go age, comma, and you separate them out. Or you could do separate lines to go synthesize age, and then underneath it synthesize, or excuse me, name, synthesize age, synthesize, and actually, believe it or not, Xcode will put this in for you automatically. When you write it, it'll actually automatically show here. So if I go back to person and take a look again, I've got the function prototypes, and this is review. Actually, we've covered this stuff already. And what do we have function prototypes for? Well, we have set age and get age. This is the accessor. This is, excuse me, the modifier and the accessors. And we're using the parameter type init here, and init's taking on x. So this is a parameter. Set age takes on one parameter, integer x, that we're going to use to set the age. We know that these are methods that are going to be inside of the class, and they're method instance methods because they have a minus next to them. And the data type that's returned for each one of the methods. We have a void and we have an integer. And then we have the end. This @end is for this interface at the top. The opening and the closing brackets here are for the data members. Only the data members go inside, which is a little different than Java. Java, we put everything inside of that. In Objective-C, we only put the data members. So this is the basic format if you missed the last class or so. That's what we talked about. We can also use this bar up here actually to switch between the two. If I switch to the .m implementation, I have @implementation up here. Person, no inheritance going on here. No colon object. That only appears in the .h in the interface class. Except for now we have this. Import person.h. So we take person.h, we import it into person.m, and we implement. So we have the implementation person, and we're going to synthesize name, because we did a property. So properties and this will actually show up for you automatically. It usually does if you're using Xcode. And then I wrote the method bodies because I didn't use synthesize. So see how integer age has these two methods that were created for it. But I don't have to do this for name, but I get the same thing. What I get is a method with the name. So I changed it. So instead of get name, if I had used synthesize, it would say age instead of get age is what I called it. So we know because usually one or two people would ask, well, if it automatically creates the accessors and the modifiers for you, or mutators, whatever you want to call it, how do we call them? Why do you call them by the name of the data member? So set something is always set age. set name, set age, set date of birth, set this, set that. They're always sets, and the gets are always give me age, give me name. So it's no give me, it's just name, age. So it's the name of the variable to return the variable. And so it automatically works for you. And we'll see that actually in an example when I look at main. But here I have the implementation, so I have age is equal to x. This is just like Java. This is just like C++. In fact, this is well, actually this is C, believe it or not, standard stdio.h. So sometimes you'll see this on the top as well, which does not appear in this example because it's already included in the namespace for Xcode, but I could do this. And if I spelled import correctly, it should work without a error message. Stdio is, for those people who studied C++, is iostream.h. It's the equivalent library, but it's for C. You can't put iostream.h in here. And you can't use C in and C out, but you can use all of the C libraries. So I don't actually have to put this line in here. In fact, if I wanted to, I could also do this and go include, because this is really going to include. And actually that would work as well. But it's already in the namespace for Xcode, so I don't have to worry about it, so I'll just take it out. Alright, so that's the printf function. The age is, and I'm printing out the age here. I went over that in the last couple of lectures. So and then we have get age, which is just going to be return age. So it's pretty simple, kind of like what we've seen so far. So now what I'm going to do is take and create an employee.h. An employee is going to extend person. So here's your cargo ship extending to ship. So this is why I say the assignments are pretty easy, because I'm showing you how to do it. And just use this as an example, essentially. So to make a cargo ship from a ship, there we go, cargo ship, colon ship. Or, well actually that's the really, cargo ships, and what was the other one? Can't remember the theme on the other one, but I remember the ships, which is the last one. Cruise ships. Now, what was the other assignment that we had other objects that were inherited from? I think we had a person. Oh, we had production worker, who's an employee. So I can go ahead and create a production worker on here if I wanted to. So here's the important part here. Inside of employee.h, we're including employee. We're importing person.h. So we always import the .h's. And now we have, instead of it coming from NS object, employees being made from person. So this is the change here in terms of the inheritance. So it says, for the interface and the interface only, we have interface employee colon person instead of NS object. And now we're setting the integer ID. Well, it's going to be not the keyword ID. It's the ID is just going to be employee ID or something. And then I decided, well, let's just go ahead and each one of these has one that's done manually and the other one using property and synthesize. So normally you're not going to mix and match this way. You're going to go one way or the other, and hopefully you're just going to do property. However, there's no reason why you can't do it the old-fashioned way. You do it because you want to change the behavior somehow. So your set or your get is going to do something different that you would not normally expect a regular set or a get to do. And then that way it makes sense to set it manually and not do the automatic property and synthesize. So add property NS string job title. It's going to give us the job title, shift supervisor, or I don't know, supervisor. And we have void set ID with an integer y, very similar to the set age, and then grow sum. Okay, so basically we're going to age the employee somehow with a method. If I look at the implementation, and grow sum is not a setter or getter. It's just a separate function that we put in there. So what do we have in here then? This is the .m file that's associated with, so it's the implementation of employee. And we're going to synthesize job title. Notice that we didn't actually have to put a pointer in here. That's the other thing to remember, because usually people go, well, what about the syntax here? NS string, well, it's a NS string object pointer to job title. So when we declare the variable with a property, the synthesize, we just keep using job title, instead we get rid of that asterisk. So over here, it's just job title that we're looking at. So that's something to get used to. which is, you know, the name of the variable, because, you know, in C, if we did that, we'd be referencing, we'd be following job title and going to that memory address. And we're just using job title because it's an object reference. So we have an initializer. So this is the new part here. So this is what you're creating in your programs. Each one of them says an initializer. This is what it means. It's like a constructor. We talked about this last time, but we hadn't actually seen the code. We did talk about initializers last time, right? I don't know. No? We didn't talk about initializers? Okay, I think I covered it somewhere along the lines. If you haven't ever heard of an initializer, it's a method that starts out with init. So this could be init employee if we wanted to. We don't actually have to say init. But if we call it init, we know for sure init. It has to have init in the name. When we call init, the main object, NS object, its constructor or initializer is called init. Self is going to be equal to super init. That's like Java saying super. So in Java, this one equals super at the beginning of the constructor. Well, there's no Java equals, but if we were writing this in Java, it would be like that, super. Well, what's that going to do for us? Well, it calls the super's constructor, which is super is in the inheritance line, is the object we inherited from. So that one's going to call the person and initialize the person object with whatever we have. What do we write an initializer person? No, probably not. So it's going to probably go back to self, or excuse me, back to NS object and just run that one. If it's not there, it's not going to run it, obviously. Return self. So ID initialize, it basically just returns itself after initializing. Initializing is going to set the data members to, you know, age is equal to 12, and this is going to be equal to that, and that's going to be equal to that over there. And so we're just using it here to initialize the super object, essentially, because we're not really setting anything else in this particular example. When you write your initializers, you could set job title. You can have initializer take on some parameters, and in inheritance example number 2, I have the initializer taking on some parameters, and then passing the parameters back to the previous initializers that are in the hierarchy. So here we're going to say self is equal to super init, which basically, we know this is a method call, I hope. We just run init on super. Super is what the object before us, which was actually person, and then super to person is NS object. Return self. And then here we have the set ID. We don't actually have anything that says get age in here. So we don't have this implemented, but we're using it in here, self get age, which is interesting. So it's going to automatically, Xcode is actually going to automatically figure that out for us and say, oh, well, we implemented it. Well, we actually have it. We have it in the interface, in the .age interface. Oh, we didn't. We didn't actually have get age in here. So this is kind of an interesting example. We're using a method we don't even have. Well, no, we do have get age. We do have get age. Excuse me, it's up here. Get age is from the person. So let me take that back. And now I remember what the example is actually showing you. Because we initialized person, we can run get age, which is actually from self. Because every employee is a person. Every person has a get age and a set age. And the employee only has the ID that's associated with it.
So when we use properties and synthesizers, we don't need int and get and set.
No, we don't have to create any sets and gets when we use synthesize.
Initialization also we don't need.
No, when you use the, no, actually, different concept. When you use synthesize and property, you don't have to create the setters or the getters. No set age, get age. However, if you want to initialize the object and set some parameters, you still have to write your own initializer. Think of the initializer like the constructor. This one here would be the default constructor because it doesn't take on any parameters. But it doesn't run automatically, so unlike a constructor in Java or C++, it's not going to run until we call it. We actually have to explicitly call the method. And we call it an initializer because it has I and IT in the name. We can call it anything we want. In Java, it actually has the same name as the class, and C++ actually has the same name as the class. C doesn't have these things, so we don't have any comparison there. But When we say super init, we're calling the initializer for super. When we say employee space init, which is what we're going to do in main, we're calling employees initializer, which is actually calling supers, which is persons initializer. Person, I don't believe we had an init, did we? Let's see. Person.m does not have an initializer. So, but we have, when we create one, we can actually, set the information, and then we can, call it and use it. So we're not actually doing very much automation in this. Alright, so we have another method implementation here called setID, and setID is taking on y, and ID is going to be equal to y, just like Java, just like before. Print out employee ID is equal to something or other. Now we're going to use the getAge from the person and increment the age in employee. So we have a function here. We can accomplish the same task in Java as well. We would actually have to go back. Actually, the same thing would work. Different syntax, but the same thing would work. What we're doing here is we have this method called growSum. And in person, we have the getAge. And the getAge is the age. So this is another example. It says we're not going to take, .age, because that's private. And it's only visible inside a person. So by default, all those data members are private. Instead, we're going to use the getAge function, which is public, to say, take this self getAge. What is my age? Well, as a person, I was initialized to something, hopefully, and then times it by 10, and then that's going to be returned. So we're returning this as an integer value from growSum. So we go out in main and take a look to see how these are actually being run. Here's our main, and here's another thing to note. We're just including employee.h. Even though I'm creating a person, I don't have to include person because employee.h is in there. It's kind of like how we're just including foundation. Everything else is in there because it's all inherited. All those classes are built on everybody else. So don't go in here and do this, although you probably won't get a message. You probably won't get an error message at all. But I think this would probably work just fine. It's just not needed. In C++, you'll get this multiple includes error message and in definition kind of thing. Java, I don't know. Java doesn't necessarily have this problem at all because we're using packages and we're importing packages. But long story short, we just have to put employee in here. Our main method, this is the main driver program, is going to take person and create, and we have to use this pointer symbol because it's an object reference. So person obj1 is equal to person alloc, and then on the person alloc that we've allocated memory for, run init. If we didn't have an init, we don't actually have to init. We could actually just create it with a person alloc, but we want to run the initializer because we actually have an initializer that's going to initialize something. It's not a bad idea to put initializers in there. So employee object number 2 is going to be equal to employee alloc. And then we're going to say object number 1 set age, object number 2 set age, demonstrating that both of them have the set age, even though employee is inherited from person. Same thing as in Java and other through inheritance, we get all the person's objects. All the person's data, all the person's member functions and everything. We don't have to re-implement them, we don't have to override them, overload them, or do anything with them. We just get them. Same as in Java, actually. Same as in C++. And when we call the methods here, we have setAge :10, which is the way we call methods and pass parameters in Objective-C. GetAge :15, and then we're gonna grow somebody. Grow results. This should really be for object2, because we're sending object2 growSum. So if we run it, we should get, the screen went away here. I closed the window on the bottom. Hopefully it will come back up. It did come back up. Here it is on the bottom. The output is on the bottom of the screen here, where we got age is 10, age is 15. And where are we getting the age is 10 and age is 15 from? Well, it's because we're printing something out. Grow results for object2. So in the setAge function up here, in the implementation, we're printing out this right here. So this is where the print is actually coming from. It's just demonstrating, huh?
What we are doing with ID?
Well, the ID, we're not really doing anything with it.
Because we use int in ID, so that's why.
Oh, no, we didn't actually. I didn't even set. You could, in fact, this is meant for you to kind of play around with. So you can download this code and try setting the ID and try passing the information back. Essentially, build from it. Try passing the information back to the using an initializer that takes on information. Actually, that would be a good exercise to do for this. But good question. Any other questions on this first example? No? Okay. Example number 2. Remember, it's inside of the folder, So hopefully this one works. This is inheritance example number 2. Squares and rectangles. What do we have here? We have an initializer that's not called init. It's called init with size. And this particular example takes and creates a rectangle and then passes back to square. Takes and passes. So this will actually show you how to send the information back through initializers. So let's see. Make this a little bit bigger so you can see it. Again, I'll figure out how to make my screen bigger in the future. So let's see what do we got here. Well, let's not look at square. Let's look at rectangle first because it's the base class. So the base class is called rectangle. We know that because it's coming from NSObject. So we say interface space rectangle colon NSObject. That's a no-brainer, hopefully. So then we decided, okay, forget about all these setters and getters and stuff. Let's just use property for everything. So this one's going to use property. And it's going to have a couple of different methods in here where we're going to say property non-atomic. Well, we can actually leave that out and just go, as we saw before, property integer, property integer height, property, or we could put them all on one line if we wanted to, and then do a correlating synthesizer. This essentially is memory related. I'm not going to talk about this today. I'm going to wait because I don't want to. My purpose of showing you this example today was to give you the inheritance part of it with the initializers. So we'll have a separate, probably not until next time or the time after that. I'll talk about non-atomic versus atomic versus weak versus strong versus some of the other settings that you can use in here. In fact, you can go like this actually, or strong, or you can actually put a bunch of stuff in here depending upon what it is. Actually, that doesn't match, so it would not be a good idea. All right, so what are we doing here? Inside of a rectangle, we're using a rectangle as a data type. So we have a reference to a rectangle, which is of the same type. So it's going to return a rectangle, which is the same thing. I don't know if, no, I didn't show it actually. We just did an int. We didn't actually return anything. Was it void? Can't remember what the initializer was in the previous example, but in this particular case, this is our initializer. It's going to be initialized with width. So we have an init width. W. So we have one parameter W, and we have a height H. So we have, this is going to be called height, and it's going to be integer value H. So we have height and width and height, excuse me, that we're going to initialize this rectangular with. Okay. Then we have a set width going to be a W, set height H, so set width, set height, and then a print. So we're going to print out, and this is the function prototypes because we're in the interface file. So if we go to the implementation file, we're importing rectangle.h, and inside of rectangle.h, what do we have? And then another thing important to note here is that we don't have any opening and closing brackets. So this usually confuses a few people. The other example I had this in it. And it had integer age or something. I don't know. It had something in there. Some opening and closing. Because we defined the interface with the data members. But because we don't actually have any data members we're using in here, you don't have to do that. So it looks like that, actually. And we know that we have the end at the end that goes along with the at interface. So that's a little bit different in terms of one of the reasons why we're looking at it this way. Okay, so if we go into the .m file, what do I have here? Let's see what this message is actually about. Edit all scope. Okay, we'll just leave it alone. implementation of rectangle, and we are including the rectangle.h, and now we're synthesizing with is equal to, what is this? Underscore w with synthesize height is equal to underscore height. So we're getting width and height in from somewhere that we're going to use to initialize, and so we're going to synthesize with it equal to particular variables. So in here we have our initialization that we're doing that's going to take in, and this is, we're still in rectangle, and rectangle is going to have initialize with height. This is the same, this is the implementation of the initializer that we saw in the previous .h file. Self is going to be equal to super, and that's always going to appear first actually. If self, if we're our self, then set the height, the width to w and the height to h, and then return self. And the self is going to be a rectangle. So if we are a rectangle essentially, because we're going to have square, it's going to be different. So because we're going to build a square on top of that. So we have set width, set height. This is the implementation. We're going to go self.width is equal to h. Self. This is like this dot width, this dot height. But in Objective-C we use self instead. Same concept as before with the w and the h. The w and h are coming in from the parameter lines. Excuse me, parameters that are being passed with the method call. And then we have for the print width is equal to height is equal to self width self height. So we've got that going on there. So it's kind of an interesting, yet very similar to the last one we looked at. If we take a look at square.h, so we have interface square colon rectangle, which means rectangle is coming from colon rectangle. So now we have an initializer is going to be initializer with size, and the square has all four sides the same, so we just need one. So instead of having a height and a width, we just have number sides or side s. And s is going to be an integer value. So we're going to return a square from the square initializer. And we're going to set the width, set the size to s. And then we have an integer size, which is going to return the size of the square. So in terms of the implementation, here's what we're looking at. What do we got? We got the implementation square, and in the square, we're going to change, we have the initializer, which is different. So initializer for a square with init with size, same name as the other initializer, but this one just takes on s. Then we create a square and we're going to return a square. We're going to run the self super init, which means run the initializer for super and make it equal to self. And the self, if we're a square, set the size to s. So the size, run set size. So set size s, and set size s is going to take the self.width and the self.height. Excuse me, this is going to be running with the integer value for s2. And then if we look at the self size implementation, what we've got in terms of that is just initialize it with self.height and self.width. Actually, basically we have one value instead of two values. We don't have a height and a width, we have just a size for s. And then we have a return, which is going to return the width. Essentially, we could actually return the height that's the same. And it's setting self width and self height, so we can actually still get back self width and self height.
Why do you inherit it from rectangle when you are doing all the
From candle?
rectangle?
Oh, rectangle. We don't have to.
You don't have to. That's what
We don't have to. Yeah, this is just a silly example showing you that you can.
because
But this
already
is-
we are doing the width and height, that is s sides. So
Yeah.
we are giving width and height.
It seems like overkill for what it is. But what it's showing you is that this is the initializer for the rectangle versus the initializer implementation for the square, which is running a set size to s down here, which in s is going to be essentially for the square is going to initialize the height and width of a rectangle. Okay, if we take a look at main, I think I've run out of squares, and okay, so good. We got squares, and if we take a look at main, what we've got here is a rectangle rec. We're using a pointer because it's a reference type. Rectangle alloc, and look at this. In it with width 10 and then height 20. And then now we're taking a square and we're running init with size, which is the name of that one up here for square, with size versus with width, which is right here, 15. So it knows to take this and set it to height and width, which is what the initializer is essentially doing. So print them. So if we print a rectangle, we get rectangle prints, and then we print a line return, and then, print out square, and then square print, and then update the square. Square set the width to 20, and then print it out again. So if we take a look at the print implementations, we don't have a print implementation, do we? We just have one in here, actually. Well, in the rectangle. I'm trying to get to the base class. Here's our print. Oops, the one down here. With our print implementation, it's going to say width and height, self width and self height. So it's going to print out the width and the height. So if we run it, we will end up with the desired output. That's going to be on the bottom of the screen here. That says rectangle, width is equal to 10, height is equal to 20, square width is equal to 15, height is equal to 15, square after change, and then basically gives us that the width was 20, now the height is 15, because we set the width on one of them. So we ran a method on rectangle from square. Same thing, very similar as before. Believe it or not, I can go through half a dozen more examples and it's all going to be the same. The third example in here works with the concept of protocols. And it's called a protocol. And a protocol. I don't know, did I cover protocols in here? Let me take a look here. Did we look at... let me see if I got protocols in here. I may have covered it for the iPhone class. Ooh, that's graphic applications. It's going to be this last one. Protocols. Let's take a look at protocols, actually. We haven't seen very much PowerPoint today, so we'll look at a few PowerPoint slides here so you get the concept. Then I'll show you the example. It's really not that hard. It's kind of like an interface. It's a rule. It's a set of rules, but it's outside of the interface concept. So what's a protocol? We actually define it as a protocol. So the formal protocols and informal protocols. Informal protocols, they are actually categories, and we're going to actually look at categories today. And we're going to look at a category in the iPhone class today. We're going to build a product with it. So there's a little bit of an overlap between these two classes, as you possibly can imagine. So, and I'll show you that protocol example next time, because I want to show you the formal method that we're going to look at in terms of the class. So formal method is a collection of methods, declarations defined independently of any class. So it's not an interface to an implementation, it's just an interface. So it's like the Java, you know, when in Java we said to extend this, implement this. It's kind of like doing an extra implement this, but this isn't part of anything. Instead of going extend, extend, extend. So it's not inheritance. It's a bunch of rules. Well, protocol is another word for rule anyway. So it implements up some rules that the class is going to implement. Maybe, maybe not, doesn't have to. But it can import the protocol and then use the protocol, which is very similar to a category. Category is sort of like a class that has functionality in it, but it's not part of any class, and it's not used in any instances of any objects. When we create categories, we use the plus symbol, because it's a class method, not an instance method. It's never a part of any instance. So we can create a bunch of instances, and then we can run this class method, which is a plus. And we can, in fact, I probably have the project out, and I can show you that one towards the end, or I'll save it for next time if I run out of time. But long story short, this is how we're getting the minuses and the pluses on those methods, and how we're exchanging them back and forth. And then let me finish with the definition. Formal protocol is a collection of method declarations defined independently of any class. It sits outside actually just sits outside in a file called protocol, or anything we want to call it. We use the @ protocol, the name of the protocol, and then maybe we're extending from NSObject, or maybe we're extending from person or employee. So this is going to be of a type that we're going to use, like protocol is going to be employee protocol or a person protocol. And then we have instance methods with the minus sign that we're putting into this particular example. We can actually put pluses in here too. That says if the class is going to use it, then we're going to have a print, a show, and a compute method that's associated with it. That's going to be part of the protocol. So adopting a protocol. Protocol 1 can be adopted by any class. What we do is go interface student, and we put the protocol in there. Using the syntax here, if it was called protocol 1 in this particular example, and it was of type NS object, it could be used in any class. So this is the name of it. That's the data type. The data type, the name of it for student. So the class student must implement the methods in the protocol P1 in its implementation, just like an interface in Java. If you use the interface, you have to implement it. Failure to implement. If the class that adopts the protocol does not implement the methods in the protocol, the compiler will issue a warning for each one of the methods that's missing. Missing this one, missing this one. It's enforcing some rules, essentially. Same thing as an interface does. As long as the adopted methods are not called, then there's no consequence for the running code. It's a warning. If you accidentally call one of them, you're going to be in trouble because it's not implemented. So you can check for conformity. So let's say you're building something bigger than these examples. You're building a huge project. And in this huge project, you don't know what you've got implemented and what you don't. You can do this method call here to check to see if it's actually implemented. So checking for conformity during the running of the program, checking can be performed whether or not a given class or a given object conforms to a protocol. So you're basically saying, are you matching? Are you implementing everything? Are you part of this protocol? So the checking is done like this here. PT is the pointer to an object. So you created a reference to the object. And protocol 1 is the pointer to the protocol. So you say PT conforms to protocol, and you're sending it protocol 1. It comes back with a Boolean, yeah, no. Which means, okay, it's okay to use. No, because if you're not conforming, you compiled and you're running it, during runtime you don't know what's going to be called, what method's going to be used. If the method's not implemented, you're going to have an issue. So the method returns true if the class of the object pointer has adopted the protocol, and false otherwise. So you run a loop or something and you go check on it, comes back true. Okay, use it. And if it's not, don't use it. If it doesn't check whether the methods in the protocol are implemented or not. So it doesn't check, it just sees if you're conforming. So it's not going to check on each one of the methods to tell you what's implemented and what's not implemented. It's just going to say, are you using this protocol? So it's kind of like, again, going back to the identity check. Sometimes in Java we put interfaces in and we implemented the interfaces. So we would all have this tagged ID. Oh, yeah, we're part of this interface. And then we check to see, is the class part of that interface? Didn't know what kind of object it was. Gave us some information about the identity. This is actually kind of doing the same thing. We check for conformity to say, are you using that protocol? Then you belong to this group of classes that uses that protocol. Then if so, then we can run this method on you because we know you have this method. It's not going to check to see that the method's implemented. It's just going to check to see if you belong to that protocol. So grouping of classes. Here we go. Protocols allow the grouping of classes and the objects according to their protocols they have implemented. This is where we get the group kind of concept in. For Objective-C, it's the same thing we're doing with tagging. I called it tagging. It's really called grouping in Java. The grouping overrides hierarchical relationships actually as well, because it belongs to groups now, because they all implement the same protocol. So then we also have this concept of declared properties, which is the second part of this lecture that I know I covered in something else. If you missed it, this is a repeat of the setters and the getters. So I thought I covered protocols last time, because I know I covered this. So, all right, that's just a refresher. Then we don't have to cover declared properties. We know about the setters and the getters and properties. So that was a repeat of something I already did, but it was like a week ago. So, all right. I didn't remember that either. Seriously, I remember property and synthesize, but I couldn't remember if we had gone over protocols.
Yeah,
so
if you might have showed an example, then surely we would have remembered that.
No, actually, so I got some looks like people had not heard of this before, so maybe that was for the new people then too. So let's take a look at protocols. So what do we got here then? All right. this is an example. It's called protocols, and it's from the downloaded examples from the week 4. So there's 3 projects in there: inheritance 1, inheritance 2, and protocols. This is all examples from the week 4 lecture. The lecture we actually covered last time, including that little bit I just recovered. Okay, so what do we got going on here? Let's take a look here. And we have a printing.h. So it's an easy quick fix here to see this project has already been built. But, and if you stick around for the iPhone class, you'll see me build a protocol. Actually, I'm going to create a category actually for that class, which is essentially is an informal protocol. We see complex H, complex M, fraction H, fraction M, printing H. Where's printing M? There's no printing M. So protocol. So then inside we have main as well. So let's take a look at printing H. We see we have the keyword protocol printing. So it's not called interface because there's no implementation to it. So we select a create protocol option, not a class, which creates just a .h file. So if I wanted to recreate this, I go File, New, File, and here I'm on Objective-C protocol. So if you hang around for the iPhone class, we're going to do a category, which is kind of the same thing. One's formal, one's informal. Category, I'm going to create a class method in there and run the class method. So if you you don't hang around for it, watch the video from today. So if you're in this class and you want to see how it applies, and I probably will end up, but there's no guarantee I'm going to remember to show you this example. But watch the video today for this next class, and you'll see this one category implemented. But for this particular one, we're doing the Objective-C protocol. I'm going to cancel this because I actually created it for you to save some time. So you select the Create Protocol option. So the interfaces in the Objective-C are called protocols. So it's equivalent, and when I say interfaces here, that's equivalent to a Java interface, as I mentioned before. Not this Objective-C interface concept. So here's a protocol for printing. So what do we got here? It's just printing. So it just says we're going to have a printing method. Why are we going to use that? I don't know. It's a stupid example, but you know, just to show you how to do it or use a protocol. We have one method, void print, and then we have an interface printing. So this is actually the interface to the protocol. So the protocol interface, not to be confused with the other interface in this particular file, determines the single method print. So the protocol is using the printing. So we're going to implement this protocol 2 ways, one with the fraction and the other with a complex number. So we go over here to fraction as an example. Fraction and complex number are 2 separate classes, both coming from NSObject, but here's the syntax. We got printing coming up over here with these colons here. What does that mean? Well, that means we're implementing the protocol printing. That's this one over here that we just looked at a few minutes ago. So we don't put implements, we don't put another colon here. We just go fraction colon NSObject, and then we do this here with the opening and closing brackets to say this is printing. And then we put in here nothing. Actually, this is just the interface. So we have a property numerator denominator. This is for the fraction actually, and then we have fraction initialize with numerator and denominator. And then over here in complex number, we're using the same thing. We have printing up here. So they're both printing. They're both implementing the protocol for printing. It's like a tongue twister. So double real, double imaginary. This is for, what is this? For complex number. And then integer with real, integer with, and then if we look at the implementations here, we're going to see print. And here's our print method. And then if we look at the implementation over here, we're going to see print. And if you're still having problems figuring out, well, this is kind of the generic pattern for the initializers. You look at these 2 initializers, they look almost the same as the rectangle and the square. It's going to follow the same pattern. Yeah. So you're going to get in this habit. You're going to go self is equal. It's kind of like putting super. And then putting underneath everything else. It's kind of redundant. in some ways, but it's good. Okay, so it makes it clear. So out of here in main's kind of not too bad. First we declare the objects, which are going to implement the interface. And then the variable ID that implements the interface. And then the reason this object is of the type ID is so that we can implement multiple interfaces. ID is a reserved word. It means it's generic. It doesn't follow any object meaning. Or doesn't mean it's an object type of any sort. Then to switch implementations, we just change implementations. So in here we have printable equals fraction. And then we have print the fraction as printable P. And up here we've got ID printable. This is what it's talking about actually. So we created a ID object called printable. ID is generic. It's implementing the printing interface. So this is basically saying create an object that's of a generic type and print it with this protocol. These objects have this. These two objects up here also have that protocol, which means when we run print, it's going to work. It's going to run the print for the associated object of what it's supposed to be. So we created a fraction, a complex, same as before. This should hopefully start looking more familiar to you as you go through more examples. And then printable print. Look at that, it's the same call to the printable interface that we created. And this is the printable interface object here. One way of using it, actually. And then printable is equal to fraction, printable is equal to complex. So we took a generic object, had it equal to this, run the printable. This, run the printable. And they both have print methods in them, so this print method will run, and then this print method will run. Now if we run it, hopefully we'll get those results, actually. So we have fraction is equal to 3/10, which is the print method there, and then complex number is going to be equal to this plus this. I have no idea, I didn't look at the code for that, but one of them is going to show you it depending upon the print method that was selected from the protocol implementation. So this actually kind of just creates an object that's kind of equal because neither of these two objects are from the same hierarchy, by the way. They're from different hierarchies. So we're still running the same method on multiple objects of different hierarchies, but they all belong to the protocol. They're all implementing the protocol. We create a protocol object, which is what we did in this line of code here. We had the different objects equal to the protocol, because they are equal, because they all implement the protocol. And then we run it on that object, and then voila, we have conformity among all of the different objects. So again, as the lecture was kind of pointing out, the PowerPoint was actually kind of pointing out, it makes, for a non-hierarchical relationship, it makes a grouping. So everybody's grouped together with the same, even though they're not part of the hierarchy, they're all implementing the same interface. So it's almost identical, and practically is identical, to the Java interface concept. But in Java, we could create multiple inheritance with that by implementing multiple interfaces that were abstract classes. It does not quite use the same way. It's not, the purpose of it isn't really, it's meeting a different objective. Instead, it's grouping classes from other hierarchies and putting them into the same hierarchy for the purposes of the protocol implementation. So if the protocol had something like, in this particular case, print as a method, well, you can run print on all these classes that have no relationship with each other. So it's not really extending them and creating a substitute for abstract classes and implementing them into similar hybrid categories of the hierarchy, which is kind of like what Java's doing. It's kind of hybriding classes amongst themselves for multiple inheritance. This, I wouldn't call it multiple inheritance. I would call it grouping. It's grouping classes together. Anyway, so again on this one here, you could definitely play around with it a little bit. It's the same example as before. You don't have any assignments that use protocols, but protocols come in handy for certain lightweight little things. So I believe that we are done for today, unless we have questions. Kind of zipped through all of those examples at the speed of light. Questions? Yeah?
You can use protocols.
If you want to use a protocol in your assignments, you can. You don't have to. Yeah. But it might actually be might be an easy way to group things together. But you're working with hierarchical relationships, though. Well, not all of them. Actually, the ticket booth guy isn't. Here, let me stop this video. So